Hi students, in this video we're going to cover the analytical problems for finding limits. So first let's look at some key properties of limits. All right, so now under these definitions we're assuming the limit as we approach a particular value exists for both of these functions. So for the first one, if we have the limit of a sum, we can take the limit of each part of the sum first and then just add them all together. If we have the limit of a product, we can take the product of the limits. If we have the limit of a quotient, we can just divide the two limit values. If we have a scalar value that has nothing to do with the limit, we can first find the limit, then multiply by the scale value. And then the limits of powers, or the limit of a function to a power, is just the limit to that power. And we have these two special trig limits that we'll see just in class and practice. And we'll probably manipulate Desmos or something to see how we arrive at those values. So the last thing is, the easiest way to evaluate a limit is to substitute the limit value into the function. If you get any number, that is the limit. The only restriction is going to be if we get some version of an indeterminate form. And for us, generally, that's going to be 0 divided by 0. If that happens, there may be some algebraic techniques that we can use to simplify the problem or remove the problematic value, and then try to evaluate the limit again. Later on in calculus, instead of using algebra, we'd use L'Hopital's rule to do this. But right now, we're just going to use some algebraic methods to find the limits for indeterminate forms. So for our first problem, we want to find the limit when x approaches 2. So again, the easiest thing to do is just try to substitute in 2. So if we substitute in 2 for x, we're going to get 2 cubed, and since that's just 8, that's the limit. For number 2, we have the limit when x approaches -1. Again, we just try to substitute in -1 and see what happens. So we get -1 squared minus 5 times -1. That's going to be 1 plus 5, which equals 6. So that is the limit. For number 3, we have the limit as x approaches 4 for cosine pi x over 3. So again, we just try to substitute in 4 for x. That would give us the cosine of 4 pi over 3. Now for my unit circle people, we know 4 pi over 3 is 240 degrees. So that means it's somewhere here in quadrant 3, which means the cosine value is negative. So that's going to be -1/2. For number 4, now we're getting into the properties of limits. So we have the limit as x approaches 5 for f of x is 4, and then the limit as x approaches 5 for g of x is 3. So if we apply these properties, this is the same as the limit as x approaches 5 of 2 f of x minus the limit as x approaches 5 of 3 g of x. And so what we've applied here is this first property. You can just split the sum or difference into each part having a limit. And then another property is that we can just move this value out, so we get 2 times the limit as x approaches 5 of f of x minus 3 times the limit as x approaches 5 for g of x. And so now we know the limit values are 4 and 3. So this is just 2 times 4 minus 3 times 3. So that's 8 minus 9, which is -1. So that limit is -1. So we do not have to do all of this when we're finding our limit. Rather, what we could immediately do is just multiply those numbers. So we know this first limit is 4, so we could have just immediately have done 2 times 4 minus 3 times 3. and apply the limits in our head without having to do all of this work. So we still get -1. B, this is the same as if we have the limit as x approaches 5 of f of x times the limit as x approaches 5 for g of x. So we are applying this property. We can just multiply the two limit values. So that's just 4 times 3. So that's 4 times 3, which equals 12. For C, this is the same as having the limit as x approaches 5. All right, so we know the limit as x approaches 5 for the product is already 12. So we already know that this is the same. This is 12 to the 3 halves, which is the same as the square root of 12 cubed, which is going to be 12 square root 12. For number 5, first we want to see if we can just substitute in 3. So that's going to give us 3 squared minus 5 times 3 minus 6 divided by 3 squared minus 4 times 3 minus 12. So that is 9 minus 15, which is -6, minus 6 is -12. And then we have 9 minus 12 minus 12. So that's 9 minus 24, which is -15, which is going to simplify to be 4/5. So substituting in 3, not a problem. For number 6, we have the limit as x approaches 6. So we try to substitute in 6. That's going to give us 6 squared minus 5 times 6 minus 6 divided by 6 squared, excuse me, minus 4 times 6 minus 12. So that's going to give us 36 minus 30 minus 6. So that's going to be 0. And then if we substitute in 6, we get 6 minus 24. I'm sorry, 36 minus 24 is 12. Minus 12 is 0. So we get this indeterminate form that we were talking about. So when this happens, we see if we can factor the problem and evaluate the limit after we maybe canceled out a common factor. So let's see how that would go. I'm sorry. Actually, let's write down. So let's call this, this is an indeterminate form. So anytime we get an indeterminate form, we want to see if we can find the limit algebraically by factoring, using a conjugate, or finding common denominators or something. So next, we're going to factor our numerator and denominator. So we're going to get, let's see, x squared minus 5x minus 6 is x minus 6 times x plus 1 divided by x minus 6 times x plus 2. So as we are evaluating our limits, keep the limit in the problem until you found a limit. So we see that we have a common factor of x minus 6. We can cross that out because x minus 6 divided by x minus 6 is 1. So this is the same as the limit as x approaches 6 for x plus 1 divided by x plus 2. And now substituting in 6 is going to yield 7 divided by 8. We no longer have the indeterminate form, so that is our limit. For number 7, if we try to substitute in 7, we're going to get the square root of 9 minus 3 divided by 7 minus 7. That's going to give us this indeterminate form of 0 divided by 0. So when this happens and we have a square root, we can multiply both the numerator and denominator by the conjugate of the square root expression. So that's what we're going to do. So this is the same as, And again, notation is important. Please don't just say this is equal to the conjugate multiplied by this fraction. So instead, we want to keep our limit. So we get the limit as x approaches 7 of the square root of x plus 2 minus 3 divided by x minus 7 multiplied by the conjugate, which is x, the square root of x plus 2 plus 3 divided by the square root of x plus 2 plus 3. So we'll put all of this like so, and actually let's stand this out just a bit. So in our next step, again, keep the limit. So this is going to equal the limit as x approaches 7. So we're going to get the square root of x plus 2 times the square root of x plus 2 plus 3 square root x plus 2 minus 3 square root x plus 2 and negative 3 times 3. So negative 3 times 3. I'm just actually showing you what we get. Now, if we were doing this like on a test or a quiz, you just write this stuff out. So in the denominator, do not actually multiply anything out. Do not multiply anything out. So now we know we know when we multiply by the conjugate, we really get the first term in the numerator squared minus the second term in the numerator squared. So we're going to get the square root of x plus 2 times the square root of x plus 2 is, of course, just x plus 2. The 3 square root x plus 2 and the negative 3 square root x plus 2 cancel, or they add to be 0. And so then we have x plus 2 minus 9 divided by x minus 7 times the square root of x plus 2 plus 3. And that is the limit as x approaches 7 of x minus 7 divided by x minus 7 times the square root of x plus 2 plus 3. So again, x minus 7 divided by x minus 7 is 1. So we're left with just the limit as x approaches 7 of 1 divided by the square root of x plus 2 plus 3, which is going to give us 1 over 6. Because the square root of 7 plus 2 is the square root of 9, which is 3. Then 3 plus 3 is 6. So we get 1 divided by 6 as our limit. For number 8, and this will be the last one, we'll talk about these manipulations of the last two in class when we actually do our Desmos activity. So for the last one, we have the limit as x approaches 0 of 1 divided by x plus 4 minus 1/4, all divided by x. So if we substitute in 0, we're going to see that we get 1/4 minus 1/4, which is 0 divided by 0. So we would still get this indeterminate form. So now our technique for this is we want to get a common denominator and see what happens. So we want to say that this equals the limit as x approaches 0. And so this part of the fraction needs to be multiplied by x plus 4 divided by x plus 4. And this part of the fraction needs to be multiplied by 4 over 4. So that's going to give us 4 over 4 times x plus 4 minus, and in parentheses, put the x plus 4 divided by 4 times x plus 4, and all of this is divided by x. So in our next step, we're going to get the limit as x approaches 0. So we're going to have 4, and then we're going to distribute this negative. So 4 minus x minus 4, and all of this is divided by 4 times x plus 4, and all of that is divided by x. So in our next step, we're going to get the limit as x approaches 0. So 4 minus 4 is 0, so we're going to get negative x. And anytime we have two denominators, we can just join them by multiplying. So we're going to have negative x divided by 4, and this x is going to be multiplied by that 4. So 4 times x plus 4. And we should notice that negative x divided by x is going to give us -1. So we get the limit as x approaches 0 of -1 divided by 4 times x plus 4. And so now we can substitute in 0 without dividing by 0. We're getting that indeterminate form. So we get -1 divided by 4 times 0 plus 4, which is -1 over 16. Okay, students, that is going to conclude our video on finding limits algebraically and using some algebraic techniques to simplify problems that give us the indeterminate form. I'll see you all in class.